Okay, I was just sitting here reforming this capacitor. It's what is it? 10,000 microfarad at 35 volts DC. I just thought maybe I explain how I'm reforming it here. This capacitor, it was old stock. As you can see, it's like brand new, but it was old stock in an electronics shop, and I bought a bunch of capacitors, and for a good price. But yeah, it was old stock before, and then I've had for almost 10 years or something now. So I decided that I was just going to reform it. So how I'm doing it is I go from the positive of the power supply to a milliamp meter. I'm just using a 1 milliamp meter for this, because you're only supposed to go to like 2 milliamps. Any higher than that, you're pretty well heating up the capacitor. So I'm just going 1 milliamp, and then I'm going to my resistor substitution box, where I can select whichever resistance I want, and depending on how fast I want to charge or discharge it, depends on if I want to charge it faster, it'd be a lower resistance. And I really want to control a little bit better, so I'm running 4.7 kilohertz, 4.7 kilo ohms. Jeez. So yeah, I just have this set up here, and then the the positive goes from the power supply to the ammeter, from the ammeter to the substitution box, from substitution box to the positive of your capacitor, and then from the negative you just go right straight to the power supply, and you just adjust it. So it's sitting there. Okay, I can give it a little bit more voltage, and when I give it a little bit more voltage, you'll see the current go up on it. So I'll bring it up to, like, let's say 0.8 milliamps, and that's almost at full scale on this this DC power supply. And you can see it starting to go down, because what it's doing is it's charging the capacitor through the resistor, but it's doing it at a slow rate, and what it's doing is it's forming an oxide layer on, I guess it would be the positive of the capacitor, positive plate. Well, it's, anyway, a capacitor this big is just wrapped around and around, but anyhow, it's depositing an oxide layer on the positive plate of the capacitor, and that's what they call reforming. And I think it's also setting up the electrolyte, polarizing. Let's put it this way. I think it's polarizing the electrolyte is what's really going on. I think it's just polarizing the electrolyte where it hadn't been used in a while and probably wasn't polarized. Everybody has different ways of looking at things, and that's kind of the way I'm looking at it. So yeah, you just raise your voltage, but raise your voltage watching your current, because, well, you can go, they say, around 2 milliamps or whatever, charging a capacitor and stuff. And where this is such a big capacitor, it could probably go up higher, but I just had this 1 milliamp meter kicking around somewhere's close, and and a couple resistance boxes, and I got a couple stuff right here. There's another that's a capacitance substitution box, and that's, I guess, capacitance substitution box. And what's that? That's my analyzer for capacitors and different meters, and there's a fair amount of stuff that's close by that if I want to do some testing or whatever, it's right there. So yeah, the whole idea is raise the voltage, watch the current, and then the current, as the capacitor charges, the current will go down until the capacitor equalizes out, right? It's going to equalize out, it's going to charge. So, and then when it gets fully charged, well then you just raise your voltage again. Now, as you can see, it's, believe it or not, it's still charging. So if I was to lower the resistance, right, you can see that's still charging. I'm just lowering the resistance so it'll charge faster, because the voltage is not changing. The capacitor is just charging. And I'm just limiting the current with the resistance of how fast this capacitor is going to charge. So that's my thoughts on reforming a capacitor, and a little bit of theory mixed in with it. So yeah, so if anybody has ever wondered about reforming a capacitor, this is how I do it. You can do it with just a power supply and a resistor and a voltmeter and obviously a capacitor, and you take a reading across the resistor, and that's your voltage drop across your resistor. And I don't know, I don't know exactly how that would work. I guess the guy just pretty well said you can see the voltage go up as it's charging and watch it go down, but you're not really understanding what the current is. So you really want to watch the current. So yeah, you could do it that way, but that's not really the way you should do it. But yeah, you could do it that way. Myself, I would rather watch the current so I know that I'm charging, and when it goes down, it's pretty well done charging. So yeah, everybody can do it whichever way they want to do it. I'm just showing my way. Everybody have a great day. Cheers.